Hello, my name is Nancy Nelly Zurita Mendez from the Universidad Michoacana de San Nicolás de Hidalgo. Today, I'm pleased to present our work entitled Sustainable PLA-based Biomaterials Incorporating Eggshell Membrane Collagen and Goat Milk-Derived Galalith for Bone Engineering. Bone tissue engineering requires biomaterials that combine bioactivity, biodegradability, and adequate mechanical performance. In this work, we select renewable material sources, including goat milk-derived galalith and eggshell membrane collagen, together with bioactive glass and polylactic acid to develop sustainable composite scaffolds. These components were successfully integrated into a porous PLA scaffold fabricated by solvent casting and salt leaching. The interconnected porous architecture was designed to facilitate cell infiltration and nutrient transport while combining the advantages of both organic and inorganic bases. As we can observe, the application is primarily bone tissue engineering. These materials can support cell attachment and proliferation, also promotes osteogenic differentiation, and enhances new bone formation. The fabrication process, well, 4 different scaffold formulations were prepared by varying derivative proportions of galalith, eggshell membrane collagen, and bioactive glass. This fabrication strategy generated highly porous 3-dimensional structures suitable for subsequent structural, chemical, and mechanical characterization. As we can observe in some evaluations, scanning electron microscopy revealed clear composition-dependent morphological difference among the scaffolds. The incorporation of collagen promoted fibrous structures, whereas bioactive glass generated mineral-like deposits. The hybrid formulation successfully combined both features within an interconnected porous architecture. FTR analysis confirmed the successful incorporation of the different scaffolds components. The characteristic PLA absorption bands were preserved, while additional signals associated with collagen and bioactive glass verified the presence of the natural reinforcement without altering the polymer matrix. The mechanical evaluations were performed by compression testing. It demonstrated that the incorporation of natural reinforcement modified the mechanical response of the scaffolds. The different formulations exhibited distinct deformation behaviors, indicating that their mechanical performance can be tailored by adjusting the relative proportions of galalith, eggshell membrane collagen, and bioactive glass. There are some conclusions that we must identify. This study demonstrates that renewable biomaterials such as goat milk-derived galalith and eggshell membrane collagen can be successfully incorporated into PLA-based scaffolds for bone engineering. This sustainable composite exhibit promising structural, chemical, and mechanical characteristics and represent a promising platform for future biomechanical and biomedical applications. What's next? Well, there are several work that will be performed in advance. But as this current work is focused on the biological validation of these scaffolds, ongoing studies include in vitro degradation in phosphate buffered saline and simulated body fluid, together with biological evaluation to assess their bioactivity and suitability for bone tissue engineering applications in future. Well, this is all for today. Thank you very much for your attention, and well, I will be blessed to answer any questions you have. Thank you very much.